Imagine dropping a steel wrench into the ocean. Within seconds, it disappears beneath the surface. Now imagine placing something made mostly of the very same material, but weighing over 220,000 tons onto that same water. Instead of sinking, it floats effortlessly. It carries thousands of shipping containers, crosses entire oceans, and survives storms powerful enough to swallow buildings. How is that even possible? Is it because of the air inside? Do the engines somehow keep it afloat? Or is there an invisible force at work that most people never notice? Today, we're uncovering one of the greatest engineering mysteries hiding in plain sight, and by the end of this video, you'll never look at a giant ship the same way again. Every day, thousands of enormous ships travel across our oceans. They deliver food, cars, electronics, fuel, and countless everyday products that millions of people rely on. Some of these ships weigh more than 220,000 metric tons when fully loaded. To put that into perspective, that's heavier than hundreds of commercial airplanes combined. Yet they float so naturally that we rarely stop to question how. Most of us learned from childhood that heavy things sink. Drop a rock into water and it sinks. Drop a piece of steel into water and it sinks even faster. So why doesn't an entire mountain of steel disappear beneath the waves? The answer isn't magic. It isn't hidden technology. And it certainly isn't because ships are lighter than water. Instead, it's a beautiful combination of physics, mathematics, and brilliant engineering. Let's begin with the first thing everyone assumes: that heavy objects always sink. Think about the last time you dropped something into water. A coin, a key, a hammer, each one sank almost immediately. Because of experiences like these, our brains naturally connect one simple idea: heavy equals sinking, light equals floating. But nature doesn't actually work that way. Imagine placing a tiny steel marble into a bucket of water. It sinks instantly. Now place a huge wooden log into the same bucket. Even though the log may weigh hundreds of times more than the marble, it floats. Suddenly, weight alone doesn't explain what's happening. Something else must be deciding whether an object floats or sinks. That something is the relationship between an object's weight and the amount of water it pushes aside. And understanding that relationship changes everything. Because the ocean doesn't care how heavy something is. It only cares about how much water that object displaces. This simple idea became one of the greatest scientific discoveries in history. More than 2,000 years ago, a Greek mathematician named Archimedes realized exactly why objects float. His discovery still guides every ship built today. And once you understand it, giant floating ships suddenly make perfect sense. But how can water possibly push upward with enough force to support something weighing hundreds of thousands of tons? To answer that, we need to meet the invisible force hiding beneath every floating ship. Imagine lowering an empty plastic bottle into a swimming pool. You immediately feel the water trying to push it back upward. That upward push isn't your imagination. It's a real force. Scientists call it buoyancy. Every object placed in water pushes some of the water out of the way. The displaced water pushes back. The more water an object displaces, the greater the upward force becomes. This is known as Archimedes Principle. Here's the remarkable part. A ship doesn't need to be lighter than water to float. Instead, it must displace a volume of water that weighs the same as the ship itself. As a giant ship settles into the sea, it sinks only until enough water has been pushed aside. At that point, the upward buoyant force exactly balances the ship's weight. Gravity pulls down. Water pushes up. The two forces become equal. The ship floats. If engineers load additional cargo onto the ship, it simply settles a little deeper into the water, displacing more water until balance is restored. This delicate equilibrium allows some of the largest machines ever built by humans to travel safely across oceans for decades. But one mystery still remains. If steel sinks, and ships are made mostly of steel, why doesn't the steel itself drag the entire ship underwater? The answer has almost nothing to do with the steel and everything to do with the ship's shape. Imagine crumpling an empty aluminum can into a tight ball and dropping it into a bucket of water. It sinks almost immediately. Now imagine taking that same amount of aluminum and shaping it into a small boat. Suddenly, it floats. The material hasn't changed. The weight hasn't changed. Only the shape has. This simple experiment reveals one of the biggest secrets behind every floating ship. A ship doesn't float because steel is special. It floats because its shape allows it to displace an enormous amount of water. Think of the hull, the large outer body of the ship. Instead of being a solid block of steel, it's a huge hollow structure filled mostly with air, equipment, and cargo space. This dramatically increases the ship's volume without increasing its weight by the same amount. As a result, the ship's average density becomes lower than the density of the water it displaces. That's the key. Imagine holding two backpacks. One is packed tightly with books. The other contains mostly empty space. Even if they look similar in size, the first feels much heavier because its weight is concentrated into a smaller volume. Ships work in the opposite way. They spread an enormous weight across an even larger volume. The ocean doesn't see only the steel. It responds to the entire shape of the ship. That's why modern ships are built with wide, carefully designed hulls. Their shape allows them to push aside enough water to generate the upward force needed to support their incredible weight. But floating is only half the challenge. A ship also has to remain balanced. Otherwise, even if it floats, it could tip over. So how do engineers keep a floating city standing upright in rough seas? Have you ever carried a heavy box? If the weight shifts suddenly to one side, the box becomes difficult to control. The same thing can happen to a ship. Every container, vehicle, passenger, and fuel tank changes the ship's balance. If too much weight gathers on one side, the ship begins to lean. To prevent this, engineers carefully calculate where every load should go. But even careful planning isn't always enough. That's why many large ships use ballast tanks. These are enormous compartments inside the lower part of the ship that can be filled with seawater or emptied when needed. If the ship begins to lean slightly, water can be pumped between different ballast tanks to restore balance. Think of it as adjusting the weights on a giant balancing scale. Modern ships are also equipped with advanced sensors and computer systems that constantly monitor their position, weight distribution, and stability. The crew receives real-time information, allowing them to respond quickly if conditions change. Another important factor is the ship's center of gravity. Heavy equipment and cargo are usually placed as low as possible. Keeping the weight low makes the ship much more stable. Much like a person standing with their feet wide apart is harder to knock over. All of these systems work together to help ships remain upright, even when facing powerful waves and strong winds. Yet despite all this engineering, ships can still sink. So what causes these giants to fail? Ships are incredibly safe, but they are not indestructible. Their ability to float depends on maintaining the delicate balance between gravity and buoyancy. If that balance is lost, trouble begins. One of the biggest dangers is water entering the hull. The hollow spaces that normally contain air begin filling with water. As more water enters, the ship becomes heavier while losing the empty space that helped lower its average density. Eventually, the ship can no longer displace enough water to support its weight. Buoyancy loses the battle against gravity. The ship sinks. Severe storms can also threaten ships. Powerful waves create enormous forces that test even the strongest vessels. Fortunately, modern ships are designed to flex slightly with the waves instead of resisting every movement. This flexibility helps them survive conditions that would destroy rigid structures. Human error can also play a role. Improper cargo loading, navigation mistakes, equipment failures, or poor maintenance can increase the risk of accidents. Fortunately, international safety regulations require ships to undergo regular inspections and follow strict design standards. Every major lesson learned from past accidents has helped engineers build safer ships for the future. Today, modern cargo ships safely transport around 90% of global trade by volume, connecting countries and delivering the goods we rely on every day. Behind every successful voyage is a remarkable combination of science, engineering, and careful planning. The next time you stand at a harbor or watch a giant ship crossing the horizon, take a moment to appreciate what you're really seeing. You're not just looking at a massive piece of steel. You're witnessing thousands of years of scientific discovery brought to life. What seems impossible at first, a steel giant floating on water, is actually a perfect demonstration of nature's laws. Gravity pulls downward. Water pushes upward. When those forces are balanced through clever engineering and thoughtful design, even a ship weighing more than 220,000 tons can glide across the ocean with surprising ease. Perhaps the most fascinating part is this: the ocean never makes exceptions. It follows the same simple rules for a tiny toy boat, a wooden log, or one of the largest ships ever built. The science never changes. Only the scale does. And that's exactly what makes our world so incredible. If you enjoyed uncovering the hidden science behind one of humanity's greatest engineering achievements, don't forget to subscribe to Beyond How. Every week, we explore the fascinating questions hiding in plain sight, from the technology we use every day to the wonders of nature and the mysteries of the universe. If you've ever asked, how does that work? Or why does that happen? You're in the right place. Join us, and let's keep discovering the science behind the world, one question at a time.